Great. Hello again, and welcome to AlphaSense office. It's not that big, but we are growing. So today's talk, it's migrating from Ingress to Gateway API. But before I start, just a couple of customs. So some drinks you can see on the table and in the fridge. Welcome to take any. Not that many. Like 5 liters with you, but just use it. And yeah, the toilets probably you already know there. And well, basically that's it. Evacuation path is that wide door in case of any emergency, but I hope it will not happen. And we are AlphaSense, and we are market intelligence and search platform. So the finance analyst using us to search across some filings, earnings, transcripts, etc. And it's quite a big thing for them. And because of that, we have a 24-ish Kubernetes clusters in our fleet to support all these activities. And some of them have those Ingress controllers we are talking about today. And my talk is not just a technical observation of what we have on the market with those ingresses, or what Ingress is, or what Gateway API is, but it's basically a story on our experience about how we migrated from those ingresses to the Gateway API. But the most important thing, so AlphaSense is hiring. And we have a few roles here in Helsinki office. We have a very nice QR code for careers page. And we actually have much more roles open worldwide. And if, in any case, you'll find a role which fits you, but not open for the Helsinki office right now, just reach out to any of our recruiters, the contacts you can find on that page, and they will be very welcome to discuss the opportunities. It's possible. Next thing, the Ingress Nginx controller itself announced that they will be retiring, and that retiring actually happened already in March this year. So no more official upstream releases, no bug fixes, no security patches. So that's one of the problems what probably should tend you to migrate from Ingress Nginx. And not just Ingress, but from Nginx. And at the AlphaSense, we have about 1,500 Ingress objects in some of our clusters on those retiring controllers, not just one controller, but controllers. And roughly 600 of them were in production, serving basically the public internet. And as you can see, the unmaintained code is in the request path of every customer request. It's a big problem. And the first generally useful thing we did was not just a technical. So we went and built in inventory, what we really have in our fleet. Every Ingress object in every cluster, and what created it, why, maybe not why, but what at least. And as a result, we got some understanding of in total of 1,500 Ingress objects, roughly, at least 64 are not really needed. because they were not controlled by GitOps, and that was beyond that approach what we were using for deploying our stuff. And 64% of the fleet were coming from the one Helm chart, because we are using the umbrella Helm chart for all of our services. Well, not all, but most of our services. And it looks like pretty easy thing to just migrate the chart itself, and yeah, the fleet will be migrated. And the 64 remaining, we are different stuff, some legacy or like third party. And out of 1,500 Ingress objects, only 120-ish were real services. So some of the services were exposing a few different endpoints. But those 120, they've been like in all, like 5 classes, I must say. So the campaign is kind of like create 120 MRs, get them merged, and that's it. But actually it was a bit more difficult. Because we didn't have like one Ingress controller, we had 5 of them. With different flavors. Some like a public one, basically what you will see when you access our, well, not the C, but when you're accessing our product, is going through the public. We have a private one for some internal stuff, service-to-service calls. We had some private links on NLBs, some restricted IP whitelisted controller, and some proxy protocol. So all that zoo had to be migrated. And one of the first things what we had to do is basically to figure out what we are going to do with the Nginx while we migrate. So, because it still was already end of life in March, and the project, like scale, is quite big. So, one of the first iterations, we are literally migrating from Ingress Nginx controller from the upstream to the chain guard Ingress Nginx fork, where they state they will be patching that Nginx and the controller for us for some years at least. But it's not enough, and it wasn't just enough for us, because the API is still frozen. So the security patches on the controller itself doesn't solve the problem what we have, what we were a few years behind the modern approach, modern way of working with Ingress objects. So, the second act, or actually first one, is choosing a controller. Because the market has a few candidates what you may choose from, and it's not that obvious on what you should choose for your particular application. We took a few controllers for evaluation, different implementation of them, like run some scoring against them, basically like operational simplicity or some security features, stability, and we got like applied some weights on the results, because we wanted not just like replace where we have right now, we wanted to basically improve our fleet, improve our installation. And we run that scoring against the Envoy gateway controller, the Easter controller, K gateway, formerly known as Glue, and the Cilium. And the Cilium looked very attractive on the paper because we already run the Cilium as a CNI in our clusters. But we eliminated that Cilium for structural reason. Its gateway data plane is shared per node proxy, so you're kind of losing the per gateway isolation. At least at that moment where we've been scoring that, because it happened in February 2026. Also, we had the K gateway as a downsider, because some of the features what we would like to use were actually a paid option. So not just like OSS, you have to pay for some of their support. Also, well, basically the winners are Envoy gateway and the Istio, and Istio behind the trunk also using the Envoy. But for Istio, we are already using it for the service mesh. And the service mesh was like our east to west traffic. And we had some problems with the Istio. Well, migrating from the sidecars to the cycleless implementation of it. And upgrade is not that easy actually, because there are like few components that you have to upgrade. So one component instead of a big control plane plus CRDs is a good thing, I must say. A lower resource overhead for Envoy gateway, or free policy types to learn instead of dozen resource kinds, independent upgrades, version skew rules, many things. So basically, out of all those scores and the factors, we got Envoy gateway as a winner, at least for us. So the second part is architecture. Well, some of the slides may be not that fancy, because my friend AI helped me to build them, of course. But easily approach is very simple. So we have some client somewhere, and we have some service inside our classes, and we had a Nginx behind the load balancer, and we just deploy the gateway, the Envoy gateway behind some other load balancer, and then somehow switch the traffic. So we waited a few other shapes early on, like chaining the two controllers, like one behind another. So it will be one switch instead of campaign. But it's kind of a big bang cutover per cluster. So, and some hostname swapping schemes, and so chaining died on the 2 proxy hops per request. Well, so it's not that easy to implement, so it will not be really working. So that's kind of like the situation what we got. So the 2 Ingress data planes for the month, as we deploying the parallel gateway installation into the cluster, but it's still workable. It still can be a project with an actual end date. So the second thing of the architecture is the gateways, because the gateway API gives you few more things against the Ingress Nginx implementation. for internal tools, at least some of them, the whitelisted gateway, the private link gateway for those NLBs, some legacy redirect for the migration itself, while we been migrating some of the services. It's actually, spoiler, already decommissioned, but for some time it was working for the redirects, like the 301s. And for internal only, we have just internal cluster IP servicing point, and so we migrated from those private Ingress Nginx controller to just the internal one. So like the services shouldn't be calling another service in your cluster through basically internet, or at least through your cloud. And as I said, the exposure stops being a per service decision. Annotations like can make a service public, but we attach it to a named gateway. So now Ingress object, I'll still call that HTTP route like Ingress object. So it attached to a named gateway, and you already knew like what the public is, or what was it? It's a org1 private link, whatever. And also in the future, you can tighten the knots and enforce some other security on your pipeline, how to get your service exposed or not exposed to the public. So another thing is what we did is like one wildcard listener instead of listener per service, because the gateway may have a bunch of listeners, and each of listener may have its own certificate, for example. But we decided to go with the one listener, one wildcard certificate, not everywhere, but in many places. And that saves a lot of manual work. Second thing is what we had to pay for that. And there are a few things what basically need to consider, because under Ingresses, the platform-wide control was like a big campaign, I must say. The edit annotations on every object across every repository, or you have to coordinate it with like every team which is using them, and it's almost not possible. So basically, if you want like to get some extra annotation, some snippet, add it to like everyone in that manner, it will be a problem. But under Gateway API, policy is an object that targets the gateway, so it inherits like every route beneath it inherits it, and it becomes much easier task to do, like to change some of the behaviors. Path escaping, so path confusing and traversal bypass, like handle better, or like slash normalization, or header underscore handling, for example. But those things are there, and you should basically evaluate your ingresses against that. At least what we had to do. And that brings us to the next part, where we had to implement some interface, how our developers, and we have like 400 plus of them, interact with our new gateway API objects. And again, we are using the umbrella chart. Who is not familiar with the term, it's basically a special wrapper chart with probably like a very huge default value file, which mostly fits everyone, like every service. And only the few of them have to adjust some of the parameters. So their override file become like pretty small and still fits all the needs of the company or the platform. So we had to split the idea into like two parts. So the gateway, or gateways and the listeners, they are basically our thing, our kitchen, our main platform. So the host names, like TLSs, there are some load balancers, and a few other things. They are kept now in the platform repository. What we have a special platform repository. So developers, they have access to them, of course, but it's not their daily task to go there. So we have more control. We are like code owners there. The platform team. So basically, more stability, more security, more fancy things. And the service teams, on opposite, they do own their own part, like paths or rewrites or some timeouts, because different teams have different needs on their endpoints, and like every time they have to play with something like CORS or auth, they do not need to reach to us. They just do whatever they need in their own repository. And we had some discussions how to do that. And the first version, or the first discussion basically, we discussed the mirroring. So we have already some part of the Ingress configuration in our umbrella chart. And if the mirroring is like, yeah, let's just copy the same thing from Ingress notation into the gateway API notation. But it's kind of a big deal. Even the teams, they shouldn't do a lot of changes, but because we can automate the changing of the code. But still, every Nginx query become very problematic. If they configured something what we do not want to have, and they, those teams, forgot to remove it, it will be kept forever, because no one really checking the stuff. So we rejected that exact mirroring. The second approach was about making it some abstracted way. Invent a small, clean vocabulary, for example, expose true or expose public, and hide everything related to the gateway API behind that abstraction. But private APIs we own forever, and every unsupported field becomes like a platform ticket. So yeah, add that, and that's the stuff that we do not want to work every day on. So instead of those two, we got with a composite. So real gateway API fields, some good, in our opinion, defaults, and some routes as a unit what development team can configure themselves. And basically the full spec available later on. It's all, of course, documented in the chart. And not just in the chart, in the documentation as well. And that is an example. So by default it will be it says one line, but it's kind of 4 lines. So we do enable the public access to that service for just those 4 lines, and that's the bare minimum what we had to introduce to those teams to get the HTTP route objects needed for them to migrate from Ingress to be created. And all the defaults, like the real defaults, like port or redirect, they are pre-configured by default, but they can be changed, of course. And HTTP to HTTPS redirect is on by default. Well, there are some discussion around that. Is it really needed or not? Because still majority of our ingresses are behind of CloudFront or other CDNs, and they still get like a direct connection via HTTP from them, and HTTP to HTTPS for the end clients resolved there. But we kept that as is, as it was before. So yeah, but let's have it. Let's have the redirect. Then we have a policy which lives on the route and not like in some policy object. So the developers do not need to write another big portion of manifest. They just need to add a few other lines. So that's our composition, basically, why it's composite. Because like the public enable basically just HTTP route. Then the coarse portion is a security policy, another manifest. And the backend traffic policy is related to that retry. Give me a sec. Hello. Yes. So guys, that's your pizza. Second batch. Yeah, and so that's our composition. So the chart picks the CRD, names it, wires the target refs, yada yada. And we decided what the translation will be an extra tool, kind of not a chart feature, and because the chart will be just like gateway API only, never need to read anything from legacy part of Ingress and do some conversion. So we just made AI skill to add those gateway API blocks into the service charts, those wrapper charts of our umbrella with all the things what they need to have, at least at the beginning. But the tool in some way become part of infrastructure, at least for short period of time, because it bumps the chart version to the version where it supports the gateway API. What does it mean? What again, we had like 120-ish of the service repositories where we had to migrate the ingresses. So that means NMR or PR created against that repository. And if the pinit version has some other problems, well, you have to update your PR. You have to deal with the teams. And that was one of the biggest lessons on that particular project. Because that work, the pinging, asking, is not like a technical, or it's more how they call like technical project management skill. But more on that a bit shortly. So 123, let's say it was 123 services. And all of them were semantically identical as a result. 89 needed literally nothing at all, so that skill converted everything very easily. So it was literally those like 4 lines. Gateway API, enable, true. The 33 needed like 1 extra line with the path override. Because the auto-derived path didn't match what they were actually serving. That's per their design. And one thing was a bit underestimated. When you ask like 15 teams or 20 teams to merge, it changed their production routing, because again, it's about the production as well. And you tell them like what you validated that against every service in the staging. They still may ask like why they need that. What's that? Why you think it will be working? How to test it? How you test it? Etc. So it's a big like bunch of work, pile of it. But as we did the benchmarking before, it made it a bit easier to convince the teams that those changes will not break anything in their production. So better to do the benchmarking before starting the actual campaign, starting those creating MRs, and give the answer of what was going on even before they asked your developers. So next act is actual migration. And in our case, our controller had some behaviors that we had to match in some capacity. One of the things like those paths that matched before on Ingress Nginx, they may stop matching because the Envoy gateway basically treat them differently. Yeah, because it was a case insensitive regex and now become case sensitive. And that's one of the things basically why I should drop Ingress Nginx. Another thing is those rewrites what some of those teams made. They can turn the whole path into the regex, and it's almost no one may knew anything about that situation. So some of the routes, because they still use it, but some of the routes they've been using it because of, well, they've been covered by the regex, and our conversion converted like in more secure regex, and that path it's not matching anymore. So it's a problem. Another thing is that trailing slash, because it is configured differently on ingresses and on the gateway API controllers on, I think, maybe all of currently available implementations, or at least on the ones which are using Envoy behind the curtains. So we had that well, it wasn't a problem, yeah, but we hit it on the dev, and like basically fix it, because some of the redirects, some of the clients' redirects may depend on that trailing slash. And duplicates and escape slashes collapsed differently on different those Nginx and Envoy implementations. So yeah, that should be tested before. So we did tested that initially, as we had some of those tests not passing through. So the configuration may look pretty nice, but still not working, just because of that. So some snippets, what we had on Ingress Nginx, were quite worst thing in our estate, I must say. And most Ingress controllers let a team inject raw server configuration through, let's say, annotation. So the Kubernetes annotation, through that you can like write wherever you want, or almost. It's the escape hatch for everything the Ingress API cannot express. So if there is no a particular thing in the Ingress API, and that Ingress API is frozen for years, basically the only way how to deal with that is to just add the snippet. And that can bring you to the situation that so after your Ingress to Gateway API migration, a missing deny rule, which someone added somewhere in a snippet, can become a security incident, because you're like exposing wherever you shouldn't expose, and you may miss it, and someone may not miss it and find it, because just a simple missing route is an outage, but you will hear about it from your colleagues like pretty soon. So, oh, it's not working anymore. Yeah, but the security stuff, it's like it's hidden. So better to get rid of those snippets if you have it, even now. So the next thing is like, when we deployed all those gateway API objects, HTTP routes, policies, etc., but accepted route doesn't mean some traffic moved. Yeah, that's a very simple version of what we have at AlphaSense. So we have some viewers or customers. They are reaching to our CDN, and then in the CDN we have some origins and behaviors, and that's the place where we do the real cutoff, the real switch. So we had to update the CDN to reroute traffic from the legacy Nginx to the gateway API. And only after that you will see some traffic, of course, obviously. Well, and that brings us to another thing. So that gateway load balancer, and you need the load balancer. And our gateway need balancer as well. And when we originally deployed those gateways to the cluster, well, not to the first one, but like the bigger one, we got that pending state on the creation, because by default it was creating just like a classic ELB, and it hit 1,000 instance ceiling. And our biggest cluster has at some time during the day more than 1,000 nodes. So we had to do something with that, and the easiest way is to switch from in-tree Kubernetes load balancer provider to some external one. And in our case, we are using AWS. So we just deploy the AWS load balancer controller and switch the gateway API objects to use that. So all the gateways created that AWS LB external one, which has more capabilities what you can use, and basically it doesn't restrict you on that 1,000 nodes count. But another thing is the DNS. Because you may forget to put your DNS controller on that migration plan. Because Ingress has some hostname, and the hostname should exist somewhere. And in our installation, we do use external DNS controller, which creates and then manage its life cycle, the DNS entry life cycle, associated with the Ingress. If you remove the Ingress, it will actually remove the, not everywhere, but in some places, it will remove the DNS record for it. So we have to teach our DNS controller, that external DNS, what we are actually doing something. Like what it should look into the gateway API, HTTP routes, manifests created for the host names to be created as well in our DNS. Also, what we have few other things deployed, like our VPN solution, which also using the gateway API and also using some internal DNSs. What it should be excluded actually. So those objects should be excluded from creation, or even from the monitoring, to like avoid any problems, inconsistency, like those service mesh waypoints, for example, or ZTNA gateways. And also, one of the things what we had to pick the right filter, because there is the one filter is a gateway namespace, and another one is like every route namespace. And what's the difference? So the gateway namespace, all the gateways what we created, they deployed into one, let's say, special namespace. Because it doesn't matter where they do exist. But the routes, they deployed by the service repositories, by the service themselves, and they exist in a variety of different namespaces. And instead of watching all of them, we can watch only the one and exclude any other optionally existing controller would also may create any of those HTTP routes, for example. Yeah, because the mesh makes the entire installation a bit worse, as the waypoints have some gateways, and also it's just messing up. And another thing is the bottleneck, which is, as I said previously, is not the technical part, it's not engineering. We had to get all like 123-ish MRs against the services, actually more, reviewed by respective team owners, service owners, and then merged by someone. And that was, I think, the longest part of the project, to get the people convinced that please click on the buttons. Another thing, so when initially we created those MRs with the skill, what we prepared, it actually had one small bug. We found it very quickly and released a fixed version, but the skill already pinned the chart to the version with the bug. So we had to update some of the MRs, well, 76. And yeah, that's one of the problems. It took a bit more time because we again had to reset approvals, get back to some of those people again, ask them, hey, sorry, can you approve it again? And the best outcome is to delete something what we had before, not just replace it. And that's basically about the private load balancer, as I said. And we also removed one of the Ingress controllers which were serving the whitelisted ingresses. And we did, again, the analysis before, what service is using what. Again, we migrated them, or basically asked them, hey guys, please update your endpoints from real HTTP Ingress endpoints to the in-cluster service names, and voila, the private load Ingress controller and the private load balancer is not needed anymore. Where we are now, as per now, or like literally this moment, we migrated almost everything except some part of production. It's happening during the American not working hours, so now it's on a pause, but that's the stuff that's literally going on right now. But we migrated, well, what we did? We did like a controller choice, of course. We migrated all the lower environments. We removed the private ingresses stuff, like completely. We removed or migrated, whoever needed, all the services which are not behind the CDN, like Argo CD, for example. And only production, well, 98% is probably not real figure, it's 100%. And production cutover is, again, it's happening per service, just to be sure that like every one of those services are working fine. And the post-migration cleanup, already 40%. What does it mean? We already removed like the code and controllers for private ingresses, for whitelisted ingresses, like for a few other things, and removed like the extra code what had been in the service repositories related to that. So it's very good figure even now. Yeah, so some other old controllers are still in flight for be decommissioned, but it will happen eventually, and as per my schedule, next week. And part 5, I'm sorry, a bit late for here. I'll go real quick for it. So, what we will tell you, some sort of it. The rollback may be the same size as the migration itself. So it's some situations it's easier to just keep moving, at least like per service. The interface between like your service and the developer or your platform component is the actual migration. So we made those stuff like to become almost one-liner and that easy for the developer. Otherwise, like it will stuck forever to get it reviewed if it will be like 50 lines. So your old controller defaults shouldn't be in your manifests. Yeah, you shouldn't like do that migration because it's not a part of your configuration. It was part of some old controller stuff, whoever put it in there. Do the analysis, like classify everything before executing the stuff, executing the migration or executing any of those removals. Because again, the path will be not the path, the path the developer is using, maybe not the path that you have in the manifest, just because of those rejects. Well, accepted, not equal migrated, of course, because if there is no traffic on the new path, and maybe something is wrong, even if you did the switch on the DNS and the CDN. The DNS doesn't come for free as well, so you have to adjust the way how you manage the DNS records for your ingresses as well, and filter out all this crap that's not needed there. And your tool will be an artifact, and if it has a bug, then you will have it in many other places. So that's not a good thing. Well, some things what we probably will be doing differently. So that snippet stuff. We didn't put a lot of time into that part, and well, it bited us once. Again, during the lower environment migration, but still. And we had to fix that for those services which had the snippets configured. Another thing, basically the people engineering thingy. Yeah, it's was called as an engineering project, but most of the time it was just like a discussion stuff. Like, do that, do this, because of that, because of that, because of this, please. And finally, we kind of moved one 1500-ish object estate from the controller, which is end of life right now, and not yet a big incident caused by the migration itself. We had a few lower severity priority incidents associated again with the snippets, but they were internal. They were not like literally exposed to anything. And they've been caught in the lower environments. So we kind of good. We checked everything in production after that. But nothing will happen. We are pretty confident that no one probably will even notice what the actual cutover will happen or already happened at some point. And that's it. That's my last slide. And I'm exactly on time.